Okay, exercise 4.2.13. Find the cofactor of 7 in this 4x4 matrix. Cofactor. Well, here's the 7, so where's that? Well, a sub what equals 7? First row, fourth column, so it's the A14 entry. First row, fourth column. So the question is, we need the cofactor A sub 14 prime. All right. A sub 14 prime would be, we get negative 1, 2, the power, 1 plus 4, times the determinant of the associated minor matrix. Okay, so we'll eliminate the row and column containing 7. That'll leave us with this little minor matrix here. We'll have to find the determinant of that. I see some zeros in it, so I'm pretty happy about that. So it's 6, 1, 0, 8, negative 2, 1, 4, 1, 0. And by definition, there's the cofactor. It's A14 prime equals negative 1 to the sum of the indices. I plus j is how we had expressed it. This is the minor matrix, capital A sub 14. We define the minor matrix stuff. So what we've got is the matrix attained from the original matrix A by eliminating the first row and the fourth column, which is exactly what we did. So let's see, negative 1 to the 5th power is negative 1. We need to take a determinant here of this 3 by 3 matrix. Let's say we expand along, let's expand along the third column because it's got 2 zeros in it. Let's do that. So expanding along the third column, we'll have 0 times the determinant of, that's for the record, I'll write it out. We'll eliminate the row and column containing that. Oh, I forgot something. The 0 means I get away with it. But let's see, we're looking at what? The 1, 3 entry. We'd actually have negative 1 to the 1 plus 3. So it's 1 times the entry 0 times the determinant of the minor matrix. All right, so let's see, we have 8, negative 2, 4, 1, 8, negative 2, 4, 1. Of course, we've got the 0 out front, so I really don't care about the other numbers. Next, we'll have negative 1 to the, let's see, now we're looking at this entry in the minor matrix. This is in the second row and third column. So that'd be 2 plus 3 is the exponent. So this negative 1 to the 4th becomes a negative 1 to the 5th. And the next term goes from positive to negative. We'll take the entry 1. So right here, we'll eliminate the row and column containing the 1, leaving us with a minor matrix, 6, 1, 4, 1. Next, we'll get negative 1 to the, moving to this 3, 3 entry in the minor matrix. So we'll get negative 1 to the 3 plus 3 times the entry 0 times the determinant of the minor matrix. The minor matrix we get from eliminating the row and column there is 6, 1, 8, negative 2. And close off my parentheses from the beginning. Okay, so there's the expansion along the third column. I like the third column because of the zeros. I could have streamlined this, so I'm just trying to teach you something here in terms of the patterns. We've got a 0 here and a 0 here, so of course those terms go away. So the actual arithmetic on the computation gives us, see, I still got that negative out front. This produces a, if you like, a positive 0. This produces a negative determinant of that minor matrix. We'll compute that in a second. Plus 0 times something or other. So the arithmetic simplifies down to that, taking the -1 to the 5th power to produce a negative. The 1, I'll just let it be absorbed, and that's an easy determinant to calculate. So taking full advantage of the zeros, we'll need see another negative here. 6 times 1 minus 1 times 4. Got two negatives here. Those will cancel out, and we end up with 6 minus 4. Looks like the determinant's 2. Sorry, the cofactor is 2. So we've got A14 prime is 2. Maybe I should express my answer more clearly. So the cofactor of entry 7 was A14. Of A14 equals 7 is A14 prime equals 2. And that's a little bit cleaner. Hey, you want to take the determinant of this 4x4 matrix? Yeah, not particularly, because we'd have to redo that, what, 3 more times? So if we expanded along the 4th column. If I were me, which I am, I'd expand along the 3rd column and take advantage of those 2 zeros. That's still 2 determinants of 3x3 matrices, which is no big deal, but there's easier things to do. We were only asked to find the cofactor, so we only found the cofactor.